Hello everyone, welcome to our live Maths A-level session. Today we have got binomial expansion. We will be looking at, oops, let me mute my microphone. So today we have binomial expansion. We are going to look at how to do binomial expansion for A-level maths, both for the first year and the second year content. I'll point out which one way is the year 2 content as we look at the topics. I've put in the description. Please check. There is a link to the questions that we are going to go through. So you can open them on your computers, and so it's easier for you to have a copy of them. I'm just setting up my my whiteboard so you can see what I can write. There's a slight issue with that, which I hope I can check. I can fix shortly. But in the meantime, please have a look at the questions. Let me know if then I will let you know when I can get this sorted. This black screen should normally be showing my my iPad, but it doesn't seem to be working at the moment. Sorry about that. I'm gonna try and restart the connection. Let's go to is this specific to an exam board? No, this is this applies to pretty much all the exam boards for Maths A-level. Really, the binomial expansion is in Edexcel, AQA, and OCR. For international boards, it is in Edexcel International and CIA as well. So if you do A-level, that's great. Like if you want to have an idea of what A-level will be like you will do binomial expansion in you would do binomial expansion in whatever board you do. You would be doing binomial expansion. So this would give you a good idea. I'm just still trying to get this sorted because basically I use an iPad and I put that onto my laptop to stream, but that bit of the connection doesn't seem to be working. So bear with me. And in the meantime, if you have done binomial expansion before, if you wanted this to be just a recap, you can check out the description. The questions I'm gonna use are there. You can start having a go at those, and we will see how the answers are gonna be. So this is not working like this. Let's stop mirroring. Yeah, I have this there. If I go there. Faizan, you're never saw IGCSEs? What have you got IGCSEs coming up? Is this for A2? It is for both A2 and AS level. It is going to be because there is in AS there is an binomial expansion, but then in A2 there is more, so it's for both of them. I mean, for IGCSEs, for exams, I I mean, I'm sure you're feeling nervous. It could be overwhelming, but make sure you revise your content. You're on top of the content, and then the key is I advise you to practice really. So make sure you solve lots of questions. Let me see. I think I might have it right. This is looking good. Right. Sorry about the delay. I finally got the connection. So I use Air server if anyone is familiar with that. That was not being nice really. But let's get started. So we're going to look at two things. It's two ways of binomial expansion. Let me know if you have done either of these, whether you're in first year of your A levels or the second year. So we are going to look at expanding a plus b to the n, and this is only valid for integer n values. So this is going to be 2 plus 3x to the 5. That's but it has to be positive and integer values. And then we are going to look at extending this. So what happens when n is not a positive integer. So this is more general. We can see we can have fractions or we can have negative values. We'll see how that works. Is this for the Excel? Yes, this is for the Excel as well as other boards, but at Excel for first year for S level or year one at Excel has this, and then the second year content is the second bullet point that we are going to look at. So let's start with expanding a plus b to the n. Suppose we have got this. I'll start with a simpler example. Say you have got 2 plus 3x squared. How do we do this? We know this the square, because of the square, this is the same as 2 plus 3x times 2 plus 3x. So this is, I'm doing this in the long method. So just so that we can see what binomial expansion actually does. Because if we had just a square, you didn't really have to use binomial expansion. You could have just written the two brackets next to each other, and you would say you multiply 2 and 2, and then you would multiply 2 and 3x. Then you would go like this. So you will get 4 plus 6x plus 6x, and then 3x times 3x, so you get 9x squared. So this is the this is going to be what we have at the end. If you simplify that, you get 4 plus 12x plus 9x squared. This is only if you only had 2 plus 3x squared. What happens if you had 2 plus 3x cubed? How can we expand this one? Faizan saying this is easy. Yep, that's good actually. Like I'm sure you have seen the expanding brackets in GCSE or IGCSE as well. We are just extending that. So let me know how you can do if you have a power of 3. We know that this is the same as 3 brackets multiplied together. And you can go along, you can multiply each of the terms together, or you can say I've already done 2 of them. So you know that this 4 plus 12x plus 9x squared is 2 of those brackets multiplied. So you can multiply by this one. And you can see that if you have to the power of 4, you can multiply 4 brackets together and so on. So this is gonna take a long time if you increase the number of if you increase the power. So this is where binomial expansion comes in. So this is I'm not gonna multiply. I'm gonna multiply this out and see. Let me know if what you get from this. So we are doing this manually in a way. So we are gonna see this and that, and then multiply each term, and let me know what you get in the comments, and then we'll see how we can do this. We can do this faster, which is using binomial expansion, just so that we can compare what we get when we do it manually. So I have got 8 plus 12x plus, so that's the first term multiplying the other bracket. Then I should have 24x multiplying 12 by 2, then 12 by 3x, 12x by 3x, that's 36x squared. And then I do the 9, so 9 times 2 is 18 x squared plus 27 x cubed. So I have multiplied each term with the other one, and you will, at the end, you should get 8 plus 36x 54x squared plus 27x cubed. So this is if you multiply each term with the terms with each other. This is what you should get. Let me know if you agree with me. And now let's see how we can do this without going through all this. We want to do this a bit quicker. So you might have seen this formula, the binomial expansion, but in general we are given this a plus b to the n is equal to a to the n plus nc1 and a to the n minus 1b plus, we'll see in a sec what these stand for, n minus 2b squared b to the r and b to the n. So what this is saying, this is basically this is a direct way of expanding what we had before, and this is a general formula for it. So let's explain what each of these terms are. So I'm going to compare it to the example that we had before. So here you have got a and b. A and b are the 2 and the 3x that we had. So in our example, a is going to be 2, and then b is going to be 3x. And then you have got an n. N is going to be 3 in the example. That's the power. And then remember, this is only valid for positive integer values of n. So that's why we have got a 3 here, and we can do this expansion. So as long as it's a positive integer, this is gonna work. So let's see how we can do this. So we said n is 3, we know our a, we know our b, and then you can see that the formula says start with a to the n. So I'm literally gonna follow what it says. So what is a? A, we said, is 2, n is a 3, so I'm gonna do 2 to the power of 3. So that's our first term. And then I'm going to have nc1. So I'll leave that there for a sec. That if anyone knows what nc1 stands for, let me know in the comments. But I'll just write the a and b terms first. So I have nc1 a to the n minus 1, but we know that a is 2, n is 3, so that's 3 minus 1, and then b. What is b? b is 3x. And then I keep adding, I go on to my next term. We have got nc2, so that's 3c2, This n I can replace that as well. That's 3c1. A, I have got a 2, 2 to the 3 minus 1. So you can see I'm just applying, putting the values in there. So 3 minus 2, and then our B is a 3x squared. So I hope you can see what the pattern is now. If you focus on the powers, you can see the first term, the power of the first term starts with a 3, then it becomes a 2, then it becomes a 1. So it keeps reducing. And then this power of the other one will keep increasing because this is having a power of 1. And then this is going to have a power of 2. The next one is going to have a power of 3, and so on. So that's the pattern that we have. The next one is going to be 3c3. And then we have got 2 to the power of 3 minus 3, which is going to be 0. And then 3x to the power of 3. So that's our last term there. Right, so this is how it works, how the formula is applied. We need to, let me highlight this. So this is what you need to know for the expansion. Yeah, let's go back to NC1. What does NC1 mean? So you said it's the factorial. It is indeed related to the factorial. Let me write what it is. It is it's written as you can call it n choose 1 and choose 2. It's basically saying how many different ways there are to choose. Say if you have 3c2, it's how many ways of choosing 2 terms or 2 objects are there from a total of 3. The idea here is, if you're wondering where it comes from, you have got different terms multiplying each other. You have got many brackets. How many terms will give you a 3x term? How many will give you x squared term, x cubed term? That's why we are using the combinations. But in terms of expanding, you need to be able to just use NC1, NC2. And where do you get those? How do we find those? So there are a few ways. One is you can use the formula for that. So you can say where NCR is equal to n factorial over r factorial n minus r factorial. So this is the formula for that, and n factorial is the same as n times n minus 1 times n minus 2, and so on. So that's, you can use the formula, or even better, you can use the NCR button on your calculator. If you look at your calculators, there will be a button, so you can just use that to give you what the value of NCR is. So in this case, let me move this down further. So let's do these things. Let's do the combinations. So if someone can tell me what these values are. And these are small values, so they're not going to be, you can remember them, or you can use Pascal's triangle to find them as well, which I'm going to write in a sec. But let me know what you have for these values. So I'm going to write these out. This is going to be 8, because that's 3 to the 2. Plus this should be 3c1 should be 3. And then I have got 2 to the power of 2, which is 4. And then I have got 3x. This is also going to be 3. times 2 to the 1 times 9x squared plus 1. Yep, 3c. 1 is 3, 3c2 is 3. Yep, thank you, Elizabeth. Thank you, Milad. So you have the correct values. Here we have got 1 times 2 to the 0 times 27x cubed. So simplifying all of this should hopefully give us what we had before. Let me know if you agree with that or if you have any differences from the previous answer. Because we have got 6 times 9, that works. That's great. 27x cubed. Okay, so let's summarize. We had the binomial expansion formula here. You have seen the pattern where we start with the first term to the whatever power we have, and then it keeps reducing. The next term's power keeps increasing. Then we have the coefficients, which come from the combinations. And the idea behind this is instead of writing out brackets next to each other and multiplying, which takes a long time, we just use this formula. The coefficients will come either from this formula or from your calculator, which is much better really, but especially if the numbers are big, or if the numbers are small, you could use Pascal's triangle. Pascal's triangle is something like this. So you start with ones, and then you add 1 and 1, which gives you a 2. They start and finish with 1 always. And then 2 plus 1 is a 3, 2 plus 1 is a 3, this is a 1, this is a 4, you add them, you add 3 and 3, you get a 6, and so on. So you always add these two terms to give you the next row. And you can see that you can check as well, these are the same as the coefficients, the binomial coefficients. So that's an alternative way of getting the coefficients. If you were to get the ones for this, you would look at the first number and you would be using this row. You can see there 1, 3, 3, and 1. Right, this is how to do the binomial expansion for positive integers n. I want to look at this question. This is from an exam paper. It says find the first 3 terms in ascending powers of x of 3 minus x to the 6. So let's do this together, expand it, and let me know what you get. You have a stat exam tomorrow. Well, don't worry about missing this one. This was on binomial expansion, so it doesn't really it's not really stat, but I hope you do well. Make sure you spend some time revise your content. What stat topics is it on though? Let me know. Oops, I'm running out of battery. That's not right with my pencil. Right, let's solve this one. So we have got 3 minus x to the 6. I'm gonna just copy the formula down quickly so we have it in front of us. I'm just gonna put it there. And let's see how this works. 3 minus x to the 6. So we always start with the first term, and I'll write that a is equal to 3, b is equal to minus x, n is equal to 6. So let's plug this in. Just one thing to be careful here is realizing that b is minus x. It's not just x. it's minus x. So be careful with that. Otherwise, let's get on. Let me know what your terms are if you get to the answer. So I'll start with 3 to the 6, and then 3 to the 5. So that I'll go down for with each term the coefficient goes down, but I have minus x to the 1 plus 3 to the 4 minus x squared. And how many terms is that? We want the first 3 terms, so that's where we stop. So if you wanted to expand the whole thing, you would have continued, but the question says first 3 terms, so you don't need to go further. That's where you stop. What have I missed? I haven't written the coefficients yet. So we have got 3 to the 6, that's this term. We don't need anything else, anything there. But here we need 6. Let me write them in a different color. So here we need 6c1 and 6c2. Those are going to be our coefficients. Then we are going to get 3 to the 6 should be 729. Then plus this is 6 times 3 to the 5. What do we have for 3 to the 5? That's going to be 243 times minus x. And then this one, we have got 3 to the 4, that's 81 times x squared. And then you should have 15 for this. Oops. 1458x plus 1215 x squared. Right, that's what you should have. Let me know if you agree with what I get. And then we can move on to the next question. So in this one, you can see that it's just saying expand the first 3 terms. You don't, you're not asked to do anything else. Just give the first 3 terms. Let's look at this one. Here, the first part is very similar. You just need to find the first 3 terms. But then the question continues. You're going to compare the coefficient you're going to compare 2 coefficients. So let's see how this works. Okay, I'm just checking if we agree. So 3,400, I'm not sure how you got that. Let me know how you got that and compare it to the values that I have. So you have first 7 topics with Excel hypothesis testing. Well, that's good luck with that. I hope you can do well with it. If you want to have if you want to solve questions, there are plenty of those on our website. Make sure you check them out. And if you have anything you struggle with, you can send a message. I can help you with that. And yeah, let me know about the 3,400, how that works. Well, I'll solve this one. So part A, let's expand. I will start with 2 plus kx to the 7. This is going to be 2 to the 7, and then we add 2 to the 6, kx to the 1, plus 2 to the 5, kx squared. That's the first 3 terms. We just need to stop there. Remember to add the coefficients. We have got nc1, n is a 7, so 7c1 and 7c2. Then let's see what values we have. 2 to the 7 is 1 to 8. Then you should have 448kx plus 672k squared x squared. Let me know if you agree with this. You can, yeah, you should get these if you use your calculator. You should get the values of the coefficients, and then I've expanded, I've said k squared times x squared. Then let's look at this second part of the question. Oops, it's already there. We are told that the coefficient of x squared is 6 times the coefficient of x. So what does that mean? Coefficient of x squared is this, and coefficient of x is 448k. So we are told what the relation between the two is. So that's part A. For part B, let's write out that statement. How can we write that out? What's the relation there? The coefficient of x squared, 672kx squared, k squared, is equal to 6 times 448k. So that's an equation we can solve. So to find the value of k, and that means we can divide both sides by k. If you find, then you should find k to be 6 times 448, and that should give you 4. So you can see how after expanding, you can be asked to, you can be given some information about the relation between the coefficients. So you need to figure out what's happening there. Usually it involves creating an equation and then solving that equation. Right, that was the second question. Let's move on to the other ones. Let me know if you have anything you want to ask with this one. So I am going to skip this one. This is very similar to the one that we just did. So you need to expand, and then it still relates two coefficients. Instead of saying one is 6 times, it's saying the two coefficients are equal to each other, and then you solve an equation to find k. So if you want to try this, have a go at it, and let me know what the answer is. Or if you get stuck, let me know in the comments. I can get back to you afterwards. But I want to move on to this one now, where we expand 1 plus x to the n for any n value. So it can be negative, it can be fractional. You know, in the previous one we said they had to be positive integers. So now we are going to look at when it is negative or fractional as well. So this is where the year 2 content comes in. So if you're doing the A level if you're in your second year, you might have seen this already. If you're just started A level this year, you may not. This may not have been in your topics yet. Any questions with two brackets? I'll have a look. I'm not sure if I included two brackets in this question pack. No, I don't think I have. But if you have anything you are stuck on, let me know. Again, as I said, I can get back to you. Is this A2? Yes, this bit is A2. So if you have 1 plus x to the n, we have got this expansion. Oops, let's write this. So we start with 1. And then we have got nx plus n minus 1 x squared divided by 2 factorial plus n minus 1 n minus 2 x cubed over 3 factorial, and you can see that this will keep going on. So this is the pattern that we have here. We start with nx and then it will increase, the power of x increases, and then you have got n minus 1 and minus 2 each time you have a higher x power. So this is, you can do this with any n, but what you need to remember is that this is, let me write that down first, valid for all n values, but x needs to be between minus 1 and 1. So the modulus of x need to be less than 1. So this is the formula you need to remember. But it's the x needs to be less, between minus 1 and 1. So that's the key. And let's see how we apply this to some expansion. So remember, it has to be 1 plus x. It can't be any in any other form. It can't start with 2 or anything else, and we'll see what that means. And it's only valid if x is smaller than 1 or greater than minus 1. So let's do an example, and then we'll solve a question. Let's say we want to expand 1 minus 2x to the power of minus 2. So let's identify each of these terms, just like what we did at the beginning. The 1 is there, so we don't need to do anything there. You just need to check that it starts with a 1. And then in the minus 2 is our n. What about x though? So in our formula, we had 1 plus x. Now we have got minus 2x. So what you need to remember is that if you don't have just a single x, you could have other terms. It could be 2x, it could be 5k. What you need to put into this is everything that's in that's your second term. So let's see. We start with 1, and then you're going to say nx. Well, your n is minus 2, and what's x in the formula is minus 2x. And then you will continue. You'll continue with n minus 1, so that's minus 2 minus 3. X is minus 2x squared, and then we divide by 2 factorial. And let's do one more term. You have got n, which is minus 2, minus 3, minus 4, and minus 2x cubed over 3 factorial. Right, let's simplify this and let me know what you get. I have a 1, then this is gonna be plus 4x, then I will have plus, this is 4, so let me write these down. So that's 4x squared. So 4 times 6, 24 over 2. 2 is the 2 factorial, x squared. And then here we are going to have a negative. That's negative, so it's a positive overall. Then I have got 2 to the 3, so that's 24 times 2 to the 3 is an 8, and I divide that by 3 factorial, so 3 factorial is 3 times 2, and then I have an x cubed. And this will give you 4x plus 12x squared, and this will be, so that's a 6, that gives you a 4, 32x cubed. And this will continue. If you want to get more terms, you could, but this is these are going to be the first 4 terms. So let me know if you have anything different or whether you agree with this. Then we can look at this one. You can have a go at solving this. So this one wants 4 terms as well. So you want first 4 terms. You will start with 1 minus 2x to the minus a half. I'm gonna just write that n is minus a half and the x is minus 2x, just like what we had before. So let's try this. This is question 4. So 1, I'm gonna just copy the formula again. All right, let's see what we have. We have got 1 plus nx, n is minus a half, and for x I have got minus 2x, and then n minus 1, so you have got half minus 1, so that's going to be minus 3 over 2, x squared is this, over 2 factorial. So that's 1, 2, 3 terms. We need the next one as well. So that's n minus 1, n minus 2, and then 2x cubed divided by 3 factorial. So you can see they are very similar. You need to make sure you follow the pattern, the formula carefully, and replace each term in the formula with what you have. Ilya, Faizan, good luck with your tests, both of you, tomorrow. I hope you do great. And let me know if you have got the answers, the coefficients to these ones. Because I have 1 plus x plus 3 over 2x squared, 5 over 2x cubed. All right, so this is the answer to the second question, and I want to move on to the next one. So we can see how what else can be asked here. You can see with this question, it was just find the first 3 terms. But if we move on to this one, you can see it's going to be a bit different because firstly, there's a fraction involved, and also the first term is not 1. So let's see what we do when that's how what the format is. So can we write it? Does this work with the formula directly? Oops. If I paste this, so remember we want let's put it there. So you want 1 plus x. So 1 plus x is, we don't really have 1 plus x. So what can we do to make that into, put that into 1 plus x form? Let me know what we can do. When is the next stream? Well, the next Maths A-level stream is next Monday. So this is every Monday. And next Monday, I'm gonna look at parametric equations. But also, if you're doing physics A level, they're on Sundays. So have a look at the program. There is a table here. Yeah, if you go to that link I just put in the chat, you can see the timetable. Right. Any suggestions? So what we can do, we don't want it the fraction like that. So we want it to be in the form 1 plus x or 1 plus something. So first of all, let's remember that this is gonna be, oops. So we don't like this third really. We don't really like the square root. So we can write this as to the power of a half. Because remember, square root is the same as power of a half. And after this, you can still go forward and write it as 4 plus x to the power of minus a half. The idea here is if you have 1 over a something to a power, it's the same as the negative power without the 1 over. So why is this helpful? Well, because it's getting closer to this form. We want it to be just a bracket to a power. But still, it's not great. We don't still have 1. So what can we do to get a 1 there? Are we going to have any biology and chemistry sessions? Maybe. To be honest, I don't exactly know. I mean, because I'm doing physics and maths because I teach them myself. But for biology and chemistry, we would need to arrange other tutors. So if they are if we can get to arranging that, if there is enough demand, basically, we could get biology and chemistry. So I mean, the next ones we would think are definitely sciences. So chemistry and biology could be the next one. Thank you, Taz. And yeah, GCSE. I do maths GCSE, but maybe sciences as well. As I said, we might go on to arrange those too. Okay, what was I think I saw someone say something about the 4. Teresa, yep, thank you. Take 4 out. That's what we're gonna do. So remember, let me write it here. This is what you do if the first term is not 1. That's very important. So if first term is not 1, you have to take out a factor. So you have to say, I'm going to factorize 4 plus x. So you can take a 4 out. That will give you 1 plus x over 4. Be really careful about the power here. The power belongs to the whole thing. Minus 1 over 2. So what I have done is taken 4 plus x and rewritten 4 plus x like that. If you want to check, multiply this bracket out, you will see that 4 times 1 is 4, and then 4 times x over 4 is an x, so it's the same thing. Then you need to do something about that power. You need to write that as 4 to the minus a half times 1 plus x over 4 to the minus a half. Yeah, thank you, Teresa. the key here is remembering that the power is for both of them. So usually students forget, that's not really visible. This is a very common mistake. This is only applied to the bracket. So make sure you remember that it's the power of the 4 as well. So once you write that, you can simplify it further. You can say this is what's 4 to the minus a half. This is 1 over root 4. So this is 1 over 4 to the half, which is gonna be 1 over 2. Oops. 1 plus x over 4 to the minus half. Right, that's great. I can see a couple of the same answers. We agree with them. And what did we achieve though now? So instead of having that fraction and a third, we now have a half outside multiplied by this expression, which is pretty much in the format that we want. So let's expand that. F of x is equal to a half. So that half is just this bit. I'll just keep it there. I'll not really do much with the while I expand. And then I will expand this times 1 plus x over 4 to the half. So that's there. Let's expand the orange highlighted bits as usual as we did before. This is our question. So we have a half, then we need n is minus a half. So sorry, one sec, I missed the 1, so we need 1 plus nx, so 1, and then we need the minus a half. I'm gonna copy drag this down here. So this is what we need. Let's make sure it's always there. So we have our 1, then nx, n is this is the n, and then this is the x in the formula. So that's n times x over 4. Then we have got n minus 1, x over 4 squared over 2 factorial. So I'm writing it as 1 over times 1 over. And then we need one more term, plus n, which is minus a half, minus 3 over 2, minus 5 over 2, x over 4 cubed over 3 factorial. And this whole thing is multiplied by a half at the front. So once you have this, you will only need to simplify the terms. Be careful, don't miss any numbers, any factors out. Let me see. So we have got, let's see what we have. A half. So I'll keep this there just to make it clear what the inside is. You should have 1 minus 1 over 8x. So that's 2 times 4 plus 3 over 128 x squared. minus 5 over 1024x cubed. And finally, you need to remember to multiply the half into the bracket. So you get a half minus 1 over 16x plus 3 over 256x squared. Oops, not x to the x. And then 5x to the cubed. Right, that should be the simplified version of the of your terms. So that was, give each coefficient as a simplified fraction. Okay, let me know if you agree with this. And that's the last one that I want to do today. So in the question pack, in the description, you will find another question, this one. If you want to try that, you can do so, and let me know if you have any questions. Let me know what you get, what answer you get, or if you want to ask me, I will get back to you in the comments. There was another one that we skipped as well, which was similar to what we did before. So thank you very much for joining. I hope you found this session useful. If you did find it useful, please hit the like button and subscribe, and share this with your friends. These sessions take place weekly on Mondays for Maths A level, and we also have Physics A level on Sundays and GCSE Maths on Wednesdays. Thanks for joining, and have a nice day.